Hello, Geometry. This is Chapter 8, Lesson 3. We just finished up a lesson on angle-angle similarity. We have two more similarity theorems. I just realized my split screen is not on. Sure, you want to see that, don't you? Okay. There we go. Hi. Hey there. Good to see you. Okay. And so these are two more similarity statements, side, side, side. We've seen that before, side, 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 and side, angle, sides. Now remember, when we're dealing with similarity, the sides have to be proportional and the angles have to be congruent. When we're dealing with congruency theorems, the sides and angles both had to be congruent to their corresponding parts. But now with similarity, the sides have to be proportional and the angles have to be congruent. So that's what the exploration would take you through here if we actually did this. They'd want you to construct a triangle that had side lengths of 5, 8, and 10, and then construct a triangle of 10, 16, and 20. You notice they're all multiples of 2, 5 to 10, 8 to 16, 20 to 10 to 20. And you'd find that measure of angle A would equal the measure of angle D. So A and D would be the same, B and E would be the same, C and F would be the same. Okay? So, similar triangles, they have proportional sides, but their angles are congruent. If you have three sets of proportional sides, then all the angles will be congruent. So that takes us to our first theorem there, the side, side, side similarity theorem. If a corresponding side lengths of two triangles are proportional, then the triangles are similar. So they said if AB over RS equals BC over ST, so AB over RS equals BC over ST equals CA over TR, then the triangles are similar. So my example here says I still need to add some more information here, but show the triangles are similar, then write a similarity statement. Okay, so let's say AB is 6, BC can be 9, and this can be 12. Now that actually might work out. Yeah, it would. 6 plus 9, that can work. And then let's say this one is 2, 3, and 4. 2, 3, and 4. So show that the triangles are similar and write a similarity statement. So when we say show that the triangles are similar, we need to show that all three sides have the same scale factor. Okay? That's what this means up here. All three sides have the same scale factor. Okay, so show that the triangles are similar. So if I go 6 over 3, that'd give me a 2. Okay, so if I try to do AB over XY, 6 over 3 is 2, but if I do 12 over 4, that's 3. That would not be similar. Okay, so I'm trying to match up some things. Okay, 6 over 3 equals 2, 12 over 4 equals 3. That's not the same thing. That's not going to work. So if we go 6 over 2, okay, so if I go AB over YZ, that would be 6 over 2, which is 3. Okay, AB over YZ, let's see if we can get another 3. Let's go BC, let's put that over XY. So BC is 9 over XY, which is 3. 9 divided by 3 is 3. You see the same scale factor showing up here. And the final one, AC over XZ, which would be 12 over 4, and that's also 3. So show that the triangles are similar. We've shown that they all have the same scale factor. That's the showing. Then write a similarity statement. So I'm going to go triangle ABC. And again, that order is important here. A, B, C. Pick your order of your first one and then match it up in your second one. AB, remember, went to YZ. So ABC is going to go ZYX. ZYX. Notice how I go up and then down in here. So ZYX. You have to get that order correct on that. So that's the side, side, side similarity theorem. The other one is the side, angle, side similarity theorem. If an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides, including these angles, are proportional, then the triangles are similar. Okay? Remember the name we gave to the triangle or the angle that was between the two sides we're working with, that was called the included angle. Included angle. So if angle x is congruent to angle m, that means the same measurement, and zx over pm equals xy over mn, then the triangles are similar. So here we have two triangles. We're going to assume that they're similar. Okay? And we can show that here. We have 55. And let's check this. Let's go this way this time. Let's take 10.8 over 6. Okay? So 10.8 over 6. If I divide that out, 10.8 divided by 6, I get 1.8. Okay, I want 10.8 over 6, so I got to go back over here. If I take 18 divided by 10, 18 divided by 10 is going to be 1.8. You see how you have the same scale factor. Okay, so let's find the lengths of x and y. Now, we don't have a corresponding part here, but let's assume, I'm sorry, this should have been in here. These are right angles. Okay, so we know these are right angles. So if I know two of my measurements, I can find the third side. So Pythagorean theorem would say x squared plus y squared equals, x squared plus 6 squared would equal 10 squared. The two legs squared equals a hypotenuse squared. So x squared plus 36 equals 100 minus the 36 over. X squared equals 64. And square root that, you're going to get x equals 8. So x would be 8 there. Now we can do the same thing on this other one. We can do y squared plus 10.8 squared equals 18 squared. We can solve it that way. Or now that we know this side, we can set up a proportion. Okay, I could go 10 over 18. 10 over 18 equals 8 over y. Equals 8 over y. Corresponding parts there. Cross multiply. 10y equals 18 times 8. That'd be 80 plus 64. 144. 144. How about that? 10y equals 144 divided by 10. That'd be 14.4. 14.4. Okay, extra practice, or examples here, page 234. Determine whether triangle RST is similar to triangle ABC. Okay, so here's triangle ABC. They want us to determine is RST similar to it. And they notice that we're doing the side, so we're checking out the side similarity. We're going to check the sides here. So RST, so if I go RS, that is the 8, that's the longest side. So I'm going to say 8 over, the longest side here is 6. So 8 over 6, that reduces down to 4/3. Okay, so there's our starting point. 8 over 6 is 4/3. Let's go to the next. So this is the longest. We're checking the longest. Let's check the middle sides. So the middle side, this is 7 over, the middle side here is 5. Well, 7 over 5 does not equal 4/3. Okay, that'd be 4/3 is about, that's 1.3 repeating. 7/5 would be 1.4. Okay, so those are not equal, so these are not similar. You can just stop right there. We don't even need to check the next one. Okay, let's check this one. RST, so our longest side, we got 12/5, that is 2.4. 2.4, so that's my longest side. So I'm going to check my longest side. 2.4 over their longest side, 6. Okay, you get weird decimals like that. You can always just fractions. That's 0.4. 2.4 divided by 6. That's 0.4. So we'll just check our decimals. See if these are all 0.4. Okay, let's check the middle sides. So I got 2 over, the middle side here is 5. 2 over 5, that is 2/5. That is 0.4. We're looking good. And check the shortest sides. So we get 1 over 2.5. 1 over 2.5. Okay, so let's divide that out, see what that gives us. What do you know? There's another 0.4. 1 divided by 2.5 would be 2/5, actually, because it's 0.4. So this one is yes, they are similar. There's your proof. Okay, the long sides are proportional, middle sides proportional, and the shorter sides. This comes down to proportions here. You're going to have several examples dealing with these proportions. Find the value of x that makes RST similar to HGK. So check our sides. RS has to match up with HG. So I know 3 over x plus 7 has to equal, okay, where's my given? What we need is, we need one set of corresponding sides with known lengths. We need one set of corresponding sides with known lengths. So 3 over x plus 7, there's something that's unknown right there. So 8, HK, first and last goes to RT. There's another variable, so let's look at this one right here. So if I go 3 over x plus 7, that has to equal 5 over 20/3. Hey, they give us more fractions. We like that. So 3 over x plus 7 equals 5 over 20/3. Cross multiply. So I'm going to take 3 times 20/3. Now here you have to be careful because you'll have to distribute. Notice the parentheses around the x plus 7. You have to distribute that in. So this is going to be 5x plus 35. 3 times 20/3, the 3 cancels. You just get 20. And we're in business. Subtract the 35 over. Negative 15 equals 5x divided by 5 divided by 5. X would equal negative 3. X would equal negative 3. Okay, so this right here, this given is going to be what our scale factor is. 5 divided by 20/3, that is 5 times 3 over 20. That's 15 over 20, which is 3/4. Okay? A number divided by a fraction, that's all that is the same as the number times its reciprocal. The reciprocal of 20 over 3 is 3 over 20. So our scale factor is 3/4. Let's check this. If I plug a 3 in here, 3 minus and minus 3 would be a 6. 6 over 8 is indeed 3/4. Okay, so it does check there. This would be 3 over 4. That side length would be 4. That side length would be 6, and our scale factors check out. Question 4, verify. That means we're either using angle-angle, side-side-side, or side-angle-side similarity. Verify that triangle RST is similar to triangle XYZ. Find the scale factor of triangle RST to triangle XYZ. So notice the 3 lengths of sides here. So we're using side-side-side. And we're just going to check this. RS goes to XY. So RS and XY should be corresponding parts. ST and XY, they're corresponding parts. And then TR and ZX. So these are lined up pretty easily for us. Now they want the scale factor from here to here. So that makes this one our image. And remember, when we do a scale factor, we do our image over our pre-image. Image over our pre-image. So if XYZ is our image, that makes triangle RST our pre-image. Our scale factor, we want to put these on top. So I want to check 28 over 12. Okay, so when I divide that, I get 2.3 repeating. If you need help with your fractions, that would be 7/3. Okay, just divide them by 4 there, 7/3. So 28 over 12 is 7/3. This is the verifying part. We're showing that we have the same scale factor. 35 over 15. Divide both of those by 5. 35 divided by 5 is 7. 15 divided by 5 is 3. 7/3 again. And the last one is 56 over 14. Divide those by 7, and you're going to get, 56 over 24. Divide those by 8. Divide those by 8. 56 divided by 8 is 7. 24 divided by 8 is 3. So we have verified it because they all have a scale factor of 7/3. Make sure you go image over pre-image. Final two questions. The shortest side of a triangle, oh no, I got one more, a couple more on another sheet here. The shortest side of a triangle similar to triangle ABC is 15 units long. So the shortest side is 15, similar to this. Find the other side lengths of the triangle. So this is going to be our given. The shortest side of a triangle similar to ABC. So our shortest side here is 6. So we have another triangle, not drawn to scale, that has a side length of 15. They want to know x and y. Okay? So we know the shortest, and that's going to be 15 over 6. We can reduce that scale factor if we want. Divide by 3, we're going to get 5 over 2. So there's our scale factor, 5 over 2. Now that's the shortest. Let's do our middle side. Okay, 15 is the bigger triangle, so this is the bigger one, even though I didn't draw it bigger. This is the bigger one. So the bigger number is going on top, so I'm going to go x has to go over 9. 5 over 2 equals x over 9. And then we're going to have 5 over 2. Sorry, that's not the middle side. That's going to be x over 7 for the middle side. X over 7. And now for my longest side, 5 over 2 equals, this should be x over 9. This should be a y. Apologize for that. Okay, so the middle side was 7. 7's the middle side. So y over 7, x over 9 for my longest one. Cross multiply and divide. When you get done, you should have x equaling 45 divided by 2, so that's 22.5. And y equals, the middle side would be 35 divided by 2, that would be 17.5. So there's your other two side lengths. Question 6 is kind of similar. The longest side of a triangle similar to this is 6 units long. Find the other side lengths of the triangle. So again, we have a triangle. The longest side is 6. So here, that 9 is the longest side, so it's going to correspond to that. So 6 over 9 is going to be our given. So our scale factor is 2/3. Okay. So 2 over 3, if I'm going to find my middle side, this is the longest side, the middle side is 7, so it's x over 7. And now I need to find my shortest side. I had my longest side, so I need my middle and my shortest. So 2 over 3 equals y over 6. To cross multiply and divide, you're going to get x equals 14/3. You'll have to leave that as a fraction. 14 to thirds, you're going to get 2.3 repeating. Just leave, or not, 4.3 repeating. Sorry, 4.6 repeating. 4.6 repeating is what you'd get there. Leave that as a fraction, 14/3. 2 times 7 divided by 3. This one, 2 times 6 divided by 3. That would be 12 divided by 3. That would be 4. So y would be 4, x would be 14/3. Okay, so the final set of questions here. Explain how to show the indicated triangles are similar. Explain how to show. So we can use angle, angle, side, 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 or side, angle, side. Okay. So they want us to show that SRT is similar to PNQ. Okay, they wrote this in the right order. That's nice. You see the two sides and the angle. So we want to try to show that side, angle, side is the way to go. Okay, so we'd say SR over PN, that is 24 over 18. Okay, SR over PN is 24 over 18. Divide those by 6, you get 4/3. Okay, so we have one set of sides. Let's check RT over NQ. RT over NQ, that is 28 over 21. Divide those by 7, and you get 4/3. So we have two sets of proportional sides, and we'll say angle R is congruent to angle N. Okay, so we can use the side angle side similarity. We've shown that the two sets of congruent sides are proportional, and the included angles are congruent. Okay, so this one, you notice all the different dimensions you see on the sides. We could use side angle side again, because this is a 90 here, or we can use side side side. Okay, let's check XZW. So XZW is similar to YZX. YZX. So starting here and going up, that's similar to starting here and going this way. So XZ over YZ. Let's check that. XZ over YZ. XZ. First two letters over the second two letters. So XZ is 12 over YZ, which is 9. Divide those by 3 and you get 4/3. Another 4/3. Okay, let's check ZW and ZX. ZW over ZX. ZW is 16. ZX, there's that 12. Divide those by 4. 16 divided by 4 is 4. 12 divided by 4 is 3. 4/3, same thing. Okay, those. So we've had side angle side. Let's just check the last one. WX and YZ. So WX over XY. XY. WX over XY. So WX equals 20 over XY, which is 15. You can divide those by 5. 20 divided by 5 is 4. 15 divided by 5 is 3. So again, 4/3. We've shown it by the side, side, side similarity there. Okay, a lot of proportions, a lot of matching up letters. If you always get confused of where you're at, try to match up. First two have to go with the first two, first and last, so forth and so on. All right, we'll see you in class. Good luck on the assignment. Oops, there we go. All right.